ever gazed up at the night sky and felt a shiver thinking about black holes? These cosmic monsters are the universe's ultimate mystery boxes. We see their effects, we know they're out there, but what's really going on inside? Today, we're going on a journey to the edge of reality itself, to explore what might lie beyond the event horizon. Get ready, because things are about to get weird. First, let's get our bearings. A black hole is what's left after a massive star collapses under its own gravity. It's a region of space-time so dense that nothing, not even light, can escape its pull. The boundary of this no-return zone is called the event horizon. Think of it as a one-way door. You can check in, but you can never check out. So imagine you're a brave, or perhaps very unlucky, astronaut falling toward a black hole. From your friend's perspective, watching safely from a distance, something bizarre happens. As you get closer to the event horizon, time for you seems to slow down. They'd see you move in super slow motion, getting redder and dimmer until you appear to freeze, smeared across the event horizon for all eternity. But for you, the experience is completely different. You wouldn't feel anything special as you cross the event horizon. You'd just drift right through. No dramatic explosion, no cosmic fanfare. You're in. Now, the real question: what happens next? This is where our current understanding of physics, Einstein's theory of general relativity, starts to scream for help. According to Einstein, all the matter that forms the black hole and everything that falls into it gets crushed into an infinitely dense, infinitesimally small point at the very center. This is the infamous singularity. What is a singularity? Honestly, it's a word physicists use when they mean we don't really know. An infinitely dense point is a mathematical breakdown. It's where the equations of general relativity give us nonsense answers like dividing by zero. This tells us that Einstein's theory, as brilliant as it is incomplete. To truly understand the singularity, we need a new theory, one that unites gravity with the strange rules of the quantum world, a theory of quantum gravity. Physicists have a few leading contenders for this theory, and each one paints a different, mind-bending picture of a black hole's interior. Let's start with the classic view, slightly modified. Some theories suggest the singularity isn't a point, but something else. For example, in string theory, the fundamental building blocks of the universe aren't points, but tiny vibrating strings. But in this picture, the singularity might be replaced by a fuzzball. The entire region inside the event horizon would be empty space with a point of doom at the center. Instead, it would be a tangled, messy ball of these fundamental strings. There's no singularity and no dramatic crushing. You would simply become part of this fuzzball, your information scrambled and woven into its very fabric. In a way, you'd become one with the black hole. Another fascinating idea is the Planck star. This concept comes from a theory called loop quantum gravity. It suggests that when matter collapses, it doesn't get crushed to infinite density. Instead, quantum pressure pushes back, stopping the collapse when the matter reaches an incredibly small but finite size, known as the Planck density. This creates a hypercompact object, a Planck star, at the heart of the black hole. Here's where it gets even crazier. According to this idea, the black hole doesn't live forever. After an incredibly long time, the Planck star bounces. It explodes outward, but because of the extreme time dilation near the black hole, what feels like an instant for the collapsing matter could be billions of years for us on the outside. This means that what we see as a black hole might actually be a star in the middle of a very, very long bounce. And the explosion, it could look like a white hole, the theoretical opposite of a black hole, spewing out all the matter it once consumed. Some have even speculated that the Big Bang itself could have been the result of such a bounce from a supermassive black hole in a parent universe. Yes, you heard that right. Our entire universe could be the inside of a black hole. Let's explore that idea a bit more. Could a black hole be a gateway to another universe? This is a popular trope in science fiction, and it's not entirely without a theoretical basis. Some models, like the Einstein-Rosen bridge, better known as a wormhole, suggest that a black hole in our universe could be connected to a white hole in another. You'd fall into the black hole and, instead of being crushed at a singularity, you'd be shot out of a white hole somewhere else, or even some asterisk when asterisk else. But before you pack your bags for a trans-universal vacation, there's a catch, a big one. These classic wormholes are thought to be incredibly unstable. They would collapse the instant anything tried to pass through them. So you'd still end up at a singularity, just a very pinched and contorted one. It would take some kind of exotic matter with negative energy to prop the wormhole open, and we're not even sure if such a thing can exist. So, while it's a cool idea, traveling through a black hole to another universe remains firmly in the realm of speculation. So we have fuzzballs, Planck stars, and maybe even gateways to other universes. What do these ideas have in common? They are all attempts to solve a major problem called the black hole information paradox. Here's the problem in a nutshell. A fundamental rule of quantum mechanics is that information can never be destroyed. Information, in this context, is the unique quantum state of every particle's position, velocity, spin, everything that makes it what it is. If you know the state of a system now, you should be able to calculate its state at any point in the past or future. But black holes seem to break this rule. Stephen Hawking famously discovered that black holes are not completely black. They slowly evaporate over immense timescales by emitting what's now known as Hawking radiation. The problem is, this radiation seems to be completely random. It doesn't contain any of the information about the stuff that fell into the black hole. So, when the black hole eventually evaporates completely, where does all that information go? Is it just gone? Destroyed forever? This paradox has been one of the biggest headaches in theoretical physics for decades. If information is truly lost, it would force us to rewrite the fundamental laws of science. This is why ideas like the fuzzball model are so appealing. In the fuzzball picture, the information isn't lost at all. It's stored in the quantum vibrations of the stringy fuzzball and is slowly and very subtly encoded in the outgoing Hawking radiation. The information gets scrambled, but it's not destroyed. It eventually gets back out. Similarly, the Planck star idea also offers a solution. The information isn't lost. It's just trapped inside the Planck star until it bounces and is released back into our universe, or perhaps into a new one. So, what is really inside a black hole? The honest answer is nobody knows for sure. We are standing at the frontier of human knowledge, peering into an abyss where our best theories break down. The interior of a black hole is a cosmic laboratory where gravity and quantum mechanics collide at their most extreme. Unlocking its secrets will likely require a complete revolution in our understanding of space, time, and reality itself. Whether it's a singularity, a fuzzball, a Planck star, or a door to another dimension, the truth is probably stranger than anything we can currently imagine. But that's what makes science so exciting. It's a journey into the unknown, a quest to answer the biggest questions the universe has to offer. And there's no bigger question than what lies at the heart of the dark. Thanks for joining me on this journey to the edge of everything. If you enjoyed this cosmic exploration, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. What do you think is inside a black hole? Let me know your wildest theories in the comments below. See you next time.